string lists and arrays, and these are classical computer programming concepts that we have with any programming language, but we are studying Python in this class. So let's look at this brief visualization here that talks about the strings. So the string is a sequence of characters. So when we type any letter on the computer keyboard, it's one character. So it can be a lowercase letter, an uppercase letter, or it can be a punctuation or a space. Whatever it is, if we press one key on the keyboard, it takes up one character. So that is, the keyboard is an input device, as we mentioned briefly last time, an input-output devices. The keyboard is the input device, and once we press the key, it takes up one character that gets stored into the computer memory. That's why the memory is also organized into locations of 8 bits or 1 byte, because one character, as we see it here, takes 8 bits or 1 byte to be stored in the memory if it is an English ASCII letter, if it is an English keyboard. So if we want to store a sequence of characters, then that is called a string. So if it is a word or a sentence, it's called a string. In terms of lists, the other visualization we have here is about the list. List is a data structure. This means it's we can have several strings stored into the list. So we can have a list of strings, one after another. So data structure means that specific data type is being stored into this data structure. In this case, it is a list of strings, but he can be a list of anything, a list of objects. He can be a list of characters. It can be a list of apples or pancakes, or a list of music or videos. So we have to give it the data type that we want it to be a list of. In this case, is a list of strings. This is specified right here. The array is very similar to the list, but the array takes up consecutive memory locations in the memory, where the first one comes right after the next one comes right after the next one. So when we are to define an array, we reserve a specific amount of memory space to fit this array. This means the size of the array is predefined, while with the string it is not. We can keep adding more strings to it, or we can remove some of it, and that's going to on the fly increase or decrease the memory space that the list is taking up. Also, this string can be stored in the beginning of the memory, this one in the middle, and the other one in the end. It is not like consecutive location as it is with the array. So each one of those has its advantages and disadvantages, and it is used in specific cases, in specific programming assignments or it is suitable for a particular purpose. So both of them has its advantages and disadvantages, and in the group activity in the second half of the class, we will do a brief research activity to understand the differences, the advantages and disadvantages of the lists versus the strings. So let's focus on the Python language, since we are using this language currently for this class. So in the Python language, the sequence would refer to ordered collection of elements or items. So the strings or the objects that we mentioned earlier are called also elements or items. So the list over here, we say he can be a list of anything. He can be strings, apples, pancakes, or something else we would like it to be. These are called, in this case, elements or items. It's easier for us to call them objects because they can be anything we want them to be. So the sequences are one of the fundamental data types in Python and are used to store and manipulate data. When we want this data to come in a specific order. So as we mentioned with the array, the memory's locations are consecutive, and the first one comes before the next one that comes before the next one. So there is a specific order. We could reorder them if we want to, in the way we want them to be ordered. Ascending order, descending order, or some other order that we like. So there are several types of sequences in Python, but the most commonly used are lists, so as we mentioned with the list, we can add, remove, and modify elements on the fly. This means as they are created or dynamically. So the list is not fixed in terms of its size or of its contents. It can be changed on the fly. Tuples are much like records in a relational database. These are like, if we have a table of records that has rows and columns, tuples would be the rows of this table. So the tuples are immutable sequences, which means we cannot change their contents once they're created. And the way we would define them is by using a parenthesis. So if we create a new tuple that contains the items 1, 2, 3, by using these parentheses, we would specify that this is a tuple. If we use the square brackets, then that would be a list. So we can see back here in our definition here, we define the list using those. So we define list using the square brackets. So the strings, we mentioned, are sequences of characters. They are immutable, meaning we cannot change individual characters in the string. So once we define what the string is, then it remains this way. For example, the classical computer science programming string, the first thing that we did last time in the first class, we created a simple hello world program in Python. What does it mean, a simple hello world program? When we start to learn programming, usually the classical first piece of code that we write is to print out hello world onto the screen. So that's what we have done in the previous class. That would be a string. Why? Because it's a sequence of characters. We have HELLO, then we have a comma, a space, then another word, and an exclamation mark. So this hello world, along with the punctuation that it has and the space, the whole thing will be a string. And then we have another data structure called range. So the range type represents immutable sequence of numbers, and it is used for iterating over a sequence of numbers. So, for example, oftentimes in computer science, we follow certain algorithms. These algorithms could be for building a data structure, they could be searching through a database, or they could be artificial intelligence or machine learning algorithms that require us to perform a repetitive action. This repetitive action is called a loop, and we have to tell it how many times to repeat itself. So usually we would set some number like repeat yourself from 0 to 10. Start with 0, increment every time, and once you reach 10, you would stop. So for that reason, we need to define a range of numbers like this, or like a range from 0 to 10. So some of the operations we just mentioned that we would be able to do this is iterating. So that's called an iterative algorithm that's going to loop through the data or through the function or method that we would like it to perform. Another application of this would be indexing. So accessing individual elements by their position. So over here in the array, we have something called a position. You see the first one, element, is at position 0. The next one, position 1. The next one, position 2. We could access any of them by using this index, or give me array at position 2. So the element in the array, there you go, element at index 8, this little square here. That's how we could reference or retrieve a specific item within this array by telling which index it is at. We could extract part of a sequence. Let's say give me the elements from 7 to 9. So that would be called slicing. So let's look at some more sequences examples here. So this kind of arrays are commonly used for two purposes, either for storing texts or letters, or for storing numbers in programming. Like we said, they can be used for any objects including any data types that we define, such as we said apples, oranges, pancakes, um, or um, more of data structures type like strings, numbers, or some other object that we need it to be. They can be customers um, of a retail store, they could be patients of a medical institution, they could be students, whatever we want them to be. But most commonly, they are used to store text or numbers. So if we are to store numbers, we would have a vector of numbers. If we are to store characters, we would have a string. And then they would be indexed from 0 to as many as we need. So we would say from 0 to n. Here's one example here. Ant and spider, man. So this is a string. It has 4 words and they're separated with space. The second one is an example of a vector that just contains numbers that are again indexed. So we have 1, 2, 3, 4, 5, 6, 7 numbers here. 8 numbers because we start from 0. So from 0 to 7. So there is a total of 8 of them. And again, any objects. So on this picture here we have objects instead of numbers and letters. We have these little houses here. We have here an array of houses. You see, each one is a different color. So the data type of this array would be a house. And we have 10 of them from 0 to 9. So if this is our array, our string, we can print a specific element by telling it its index. So if we want to print what is at index 4, we would give the name of this string and say print square brackets and then 4. So if we're to do this, the letter A would be printed. If we say print number 15, the letter M would be printed. If we say print number 20, we're gonna get an error because there is no number 20 here. So certain operations can be performed with the strings. These are the operators that can be used for strings. These are much like the mathematical operators: addition, multiplication, division. So the addition, a plus sign, would be used for concatenation. This means we can add 2 strings together. First, so if we have, let's say, and that's the first one. Spider-Man is the second one. If we say first one plus second one, then it's gonna create one big string with both of them together, where the second one will go after the first one. If we use the star or the multiplication sign, This means repetition, that is, we can replicate the string, have it repeat as many times as we want to. Over here we have seen string array and then give the index number for this array. So that would be indexing. We're gonna print an element at location number 4, what we have seen here. If we want to print a sequence of locations, we can say print from, let's say, from 8 until 10. So we will come here and say 8 colon 10. So it's going to print those three, the contents of those 3 array locations. We can say, in string locations, we can say we want to know how long is the string. So how many characters it has. This one has 18. We can see that because they are written over here, the indexes from 0 to 17. But if we don't know how many there, we would like to know this, then we can say give me the length of the string by using this len function. And then in parentheses give the name of the string we would like to know the length of. We could loop through all of the characters that are in the particular array, starting from the first one all the way to the last one. We can use a loop, like a for loop is what is given here, that will allow us to iterate through the string. So let's look at some simple code examples here. The first thing we have here is a string called h1, which is the Ant-Man. And so we have here in Python code, h1 becomes equal to Ant-Man, where the Ant-Man is in quotation marks, which means that it is a string. So if we write this code in Python, h1 becomes equal to quotation marks Ant-Man, close quotation marks. This means we have just defined a variable called h1 that contains the string Ant-Man within itself. If we do this, here's what happens in memory. 1, 2, 3, 4, 5, 6 memory locations are taken up, and consecutively the characters are placed within them. The second one is pretty much the same thing, but instead of Ant-Man it says Spider-Man, so that it takes 9 memory spaces. Once we have defined those 2 strings, we can do different operations with them. So let's say we would like to take the first 3 elements of this array, of this string, and place them into a new variable called animal heroes. So 0, 1, and 2 would be placed in here because that's an ant and that's an animal. And then we can take from the second string, from 0 to 6, which is the spider, which again is an animal. So the part of the string, second string, that contains an animal is the word spider. So that's why we have here from 0 to 6. And then we can ask, oh, what is the length of the animals altogether into these two strings? Because first we took the ant, then we took the spider, and we have added them together. This means we use the plus operator, that's concatenation. We added the ant to the spider, and we can ask, well, what is the length of this? So if we are to concatenate the entire thing together, ant, man, spider, man, we have 6 characters here, and we have another 9 in the second one. So that makes a 15 altogether. However, we added the word and in here as well, so that makes it 18 altogether. See, the word and wasn't here, it was just Ant-Man, Spider-Man, but we said Ant-Man and Spider-Man, so that made it a total 18. Okay, so let's look at the arrays a little bit so that we can cover those as well. Okay, so this right here is kind of important, so I want to show this real quick. What we mentioned in the beginning is that the memory, the computer memory, is organized into 8-bit locations because one character that we press on the keyboard takes 8 bits, which is 1 byte. So originally, when the computers memories and hard drives were first designed, we took that into consideration, and that's why we designed the memories of that size, and they have stayed like this ever since. But this, I said, this is the case if it is an English ASCII keyboard. What is an ASCII keyboard? This right here's the ASCII keyboard. You can go to www.asciitable.com and find out you will see the table that we're showing here. So this is basically showing the binary encoding of each character that we press onto the keyboard. So you can see your decimal, hexadecimal, and octal. So each key on the keyboard would have a specific binary number that is assigned to it that's going to take 8 bits. So this here is the space bar, here the exclamation mark, all the punctuations here, ampersand, brackets, plus sign, division sign, then start all the numbers from 0 to 9. Then they start all the letters, first the capital letters and then the lowercase letters. And each of those has a unique binary code that once we press it, given as an input and stored in the memory so that we know this is the particular key from the keyboard that we pressed. Now, I said this is if it is English letters. Now, it can be other languages like German, French with accents, or Chinese with their special characters. If that is the case, we will use Unicode. So that's gonna take up a lot more than 8 characters. It'll be like 16 or 32, depending on what we are trying to represent. Okay, we have already seen the indexing and the slicing. Let's just try to talk about the look at a few methods here that are also available, and then we look at the arrays. So we mentioned there's certain function that we can call onto the string object in Python that was length. That's gonna give us the length. In addition to the length, there's a couple of other functions we can call that are shown here. The upper and the lower parts is gonna give us the last part of the string and the first part of the string. We can look or search through the string, so we can do find and replace. We can search for a particular string that starts with particular letter, or a segment of the string that starts with particular letter or character. We can ask if the string contains letters or numbers. Is this digit or is this alphabetical? So an example with find and replace. Let's say we have a string called text. We want to replace the letter O with star. So we will say text.replace O, comma, star, where the strings are enclosed in quotation marks, and that's how we know that they are strings. See, if there were no quotation marks here, this would mean something completely different, because the star is a mathematical operator of multiplication. So it is a special sign that is reserved in Python and all other languages for multiplying numbers or strings or some arrays, something else you would like to multiply. So in order to tell this is not your multiplication sign, this is a string, a character, we have to give those quotation marks. So let's look at the arrays real quick. Okay, so let's see if we can try a quick exercise here while we're talking about the arrays. You please go to your online GDB account and try this code right here. So we want to write the code that prompts the user to enter a sentence. So you can define a sentence, and then want to ask the user to enter something, and you would store that into the sentence string. So try to do this. Just take about a few minutes. Think about it. And we will start talking about the array. The arrays and the lists and the strings are very similar to each other. That's why they're all covered into the same lesson here. The arrays would look very similar to the strings we have seen. They are data structures. They will store a collection of elements. As we said, these elements are objects, right? They can be anything. They can be apples, oranges, music, videos, anything we want them to be. The thing about it, we have even seen one earlier that was a house. A house object. They can be cars or houses. The thing about it is they are of the same type. So we have to tell the array of what kind of objects we want it to contain, and whatever type we give it, this means all the objects in the array are going to be apples, or all of them are going to be houses. Going to something that we'll do in our exercise with your group. What is the difference in advantages and disadvantages between the arrays and the lists? The arrays are fixed size. We already mentioned this. So the arrays, we have to tell them how many elements we want to have in the array. Let's say we want to have 9 elements from 0 to 8, and all of them are going to be apples. On the list, we don't have to do that. We just say we want to have a list of apples. We don't know how many. We could have 2 now and another 5 later on, till 1 more later on, till they become 9. So let's see advantages. The arrays might be advantageous over lists. It depends on our programming task and what we're trying to do. If we know in advance how many elements we're going to have and we are sure that they're going to stay like this, they're not going to change, then we can have the array because specific amount of memory is reserved, and array is a fixed structure that could be easier, faster to search, to retrieve, and so on. The lists, because they are, each element as it could be on a different memory location, they might be slower to search through them and to reorder them and things of this nature. So it depends on if it is some really huge graph or some big data thing, then it makes a difference about the time it takes to search and reorder them. Okay, so we said they can hold only one type of elements and they have a fixed length. The lists on the other side So, can you explain what the array is in simpler terms? So, the array is a contiguous location, memory locations of same data type. So, as we said, data type can be any object, such as house, car, orange, apple, or video, or music, or something else. And we basically place those in like a vector looking structure like this. So we're gonna have 10 of them. So we're gonna have 10 apples in here, from number them from 0 to 9. So that is to explain the array, to answer the question you gave. Okay. So let's go back here. Get rid of the edit bar. Edit bar? Okay, I'm removing the edit bar. Okay, so let's get back to the arrays here and the strings and the lists. So the list would store collections of items, same like the arrays, but the difference is here. The lists are more versatile because they can grow on the fly. We can make the list longer or shorter as we need them. And there are certain lists that can hold elements of different types. And the elements can be changed or modified. So this is gonna be part of your exercise with your group, so please make a note of the slide number 32 here. We will be working on researching this question in the group activity. So what would be the advantages and disadvantages of lists and arrays? Arrays versus lists, and advantages and disadvantages of each. So please save the slide and you're gonna research with your team the advantages and the disadvantages. But briefly to mention a couple: performance and efficiency. As we mentioned, if there is lots of items and to be stored as in some big data, then if we have an array, searching and sorting through the array is going to be much quicker, because the list It's going to have pointers from one memory location to another. And if it is not a single computer but some kind of cluster, it could be even on different computers and disks altogether. So searching through that list is going to be much slower. So that's just one hint here. Memory efficiency and performance efficiency. And then we need to understand, well, what do we need it for? What are we trying to save here? So these need to be taken into consideration. Here was a picture we have seen earlier of array of 10 elements from 0 to 9, that the elements were houses. As you can see, they could be different colors, but each of them are houses. Kind of actually look like the same type of house as well, only its color is different. If that's the case, then we need an array. So here's the array. To define the array in Python, what we need to do, we're going to import the library called array. Then to create the array, we say we're gonna have an array of integers, or we want to have array that contains the numbers from 1 to 5. 1, 2, 3, 4, 5. So we're going to say numbers becomes equal to array.array, and then we give it what numbers we want to store into this array. We could define it without giving the values. We could just say, well, I want to have an array of numbers that's going to be of size 5. What is in there, we didn't say. So basically, whatever happens to be there in the memory, some random junk, is going to be in our array until we tell it the numbers we would like to store. The second one, grades, is, so what you see here, the letter I means it's integer. That is an array of integers. The second one is array of floating point numbers. This means they have a decimal point, and if we want to have an array of floating point numbers, we say f, and then we give it for floating point, and then we give it those numbers: 85.5, 90.0, 92.5, and 88.75. Once again, we're not required to give the numbers. We can just say I have an array of floating points, 5 of them, and later on I will tell you what they are, or they might be being calculated on the fly and populated in here. For example, some customer placed an order. We want to have an array of all the orders for today, so they will be stored in here as they come in. Once we have them, we can print them out. So we can come out here, say print the numbers, and so the first array will get printed out, and we say print the grades, and the second array will get printed out. We could access a specific element within the array by giving it its index number. So print numbers at index 0. It's gonna give the first element because the array is indexed from 0 all the time. So there are 10 elements, they are indexed from 0 to 9. So if we say give me a position 0, that's the first element. We could change the contents of the array once. If we want to replace some numbers, we could do this. We could come out here and say the element at position 1, change it. Right now it's equal to 2. I want it to be equal to 10. So I say numbers position 1, it becomes equal to 10. And then instead of 1, 2, 3, 4, it will print 1, 10, 3, 4. Let's look at the list now. List is a little bit more complex structure. It might look as an array, but in memory it doesn't look like this. The first element can be sitting here. The second one could be way farther down into the disk. The third one could be all in another computer altogether if there's a cluster or some one that's got multiple disks. So wherever we've got space, that's where it fits them in. And because they could grow or shrink, so we don't know how many we're gonna have, so there's no way we could specify a contiguous block of memory. And that's why it just fits them as they come in. So the first one will point to the second one, it's gonna point to the third one, and the last one is gonna point to the first one. Basically, there are pointers in between them and the way they are implemented. So we want to have a list that contains the month of the year, so January, February, March, April, and so on till December. That's 12 of them. Then we just create a list called months and assign it these values. If we know they're going to be numbers and not strings, we can say that it's a list, a vector list. And just use the square brackets and say 1792 where they're separated with commas. Much like the arrays, we can print specific element or access specific element by giving its index. So if we say print from the vector list the number 1, then it's gonna print whatever is at index 1. Now remember, that's not, 1 is not the first but the second thing that we have. The first one is 0, first index is 0, second index is 1. So in that case, if the vector list is 179, then the number 7 will be at index 1. We could change things. We can say location 1, I no longer want you to be equal to 7, I want you to not be equal to 10. If that's the case, then we say vector list location 1 becomes equal to the number 10, and so the vector is going to change into this 11092. The same as with the strings, we have a couple of predefined functions or methods that can be called onto a list. The interesting and important ones are the sorting. We could sort the list. We could sort it in ascending order or descending order. Let's say the list is 23, 51, 34, 16. Well, we want it to be sorted. Smallest number, next bigger, and find the biggest one. If we say a.sort, it's gonna sort them like this, in ascending order. We could say descending order, reverse, biggest one first, smallest one last. We can add lists together by using the plus sign. We can multiply lists by using a multiplication sign. This means repeat them. An element can be removed from the list or inserted into the list, or if we want to, we can delete all of them by using the clear method. We could also have a multidimensional list where we basically have 2 or 3 or more lists one after another that kind of look like a matrix. If that is the case, we would use a double index. So instead of position 1, we also have to, that's the row, we also have to say the position in a column. So position 1, 2 would be row 1, column 2. And that's how we would index this kind of matrix looking list or array. So that is all that we have for the strings, lists, and arrays today, and we will now take a 5-minute break. And when we come back from the break, we will be working